Hi everyone. I'm Glenn Wilcox, Associate Professor of Architecture at the Taubman College of Architecture and Urban Planning at the University of Michigan. Welcome to my introductory course in 3D computer modeling. In this video, I'm going to tell you a little bit of what the course is about, what we're going to cover, and give you enough information so you can decide whether or not the course is the right fit for you. The software that I've chosen for this course is Rhinoceros, made by McNeil. Not only is it an incredibly versatile modeler, but it has a vast community of users, developers, and educators worldwide that contribute to the highly developed culture around the program. In addition, McNeil offers a free, full functional trial version of the program for 90 days, so you can download and use all of the software that you need for this course at no cost to you. I'm a designer and a maker and have been a design educator teaching in the field with computers for 25 years. So my take on using and teaching 3D software leans towards how we can apply them in a design education towards design exercises and problems. I'm less concerned with knowing and memorizing every single tool and operation in the software before we do something with it, and more concerned with working with what we know at the moment and subsequently building upon that knowledge. So what does this mean for the actual structure of the course? Throughout the 4 weeks of the course, I'm going to introduce the software to you in bits and pieces that build upon each other progressively. So I begin telling you about only the things I think you need to know to be able to work on the first assignment, then the second, and then the third, and so on. These assignments will build in complexity as you become more familiar with the software tools and processes. So why do I teach software in this way? I found that one of the major pitfalls in teaching software is not a lack of information, but in having too much. 3D modeling software presents a bewildering array of possibilities and an equal amount of online resources that discuss them in detail. This can overwhelm the beginning student, and it can be very unclear where and how to begin and what they should know, and more importantly, how they can use it. In my teaching methodology, I try not to overwhelm you with too much information, but understand that comprehension and complexity will occur over time through direct application and design exercises. To me, there are two poles to both learning and using software. At one end, there is a free-form approach, and at the other, a structured approach. Both poles will be addressed in the course, as I think they both have value. So what do these terms actually mean on the ground for what we will be doing in the course? By freeform, I mean working on exercises that don't have highly specified outcome, which means we're not going to try to model X thing at a precise scale, but trying to model something that has more of a feeling, impression, or characteristic. It is something or some space that we are modeling, but it's not predetermined. However, let's be clear and not confuse freeform with doing anything or absolute freedom. There will be a set of guidelines, rules to follow, and specific processes to use. These are perhaps a bit akin to having a list of ingredients and a recipe for a cake whose resultant form and taste could vary greatly. We will work with free-form approach in the first 2 weeks of the course. In week 3, we will move into a more structured approach to modeling, in which we are constructing specific things in a more progressively precise manner, beginning with singular object forms and moving into objects that are assemblies of parts. In order to do this, we'll need to be more comfortable with the modeling interface and have familiarity with a range of tools, experience garnered from the first 2 weeks of the course. In the final week, we will start with a structured approach, working with modeling specifically shaped, smooth forms, touching on a few advanced tools and methods before we return to a final free-form project in which I demonstrate a procedural methodology for creating a computationally rich design project. So what I've done in designing this course is to cover every tool and aspect of the software that I believe a beginning modeler should know by the end of 4 weeks, and do that through a series of assignments that would be both enjoyable and challenging, that would get you thinking about the role that a computer plays in a design process. By the end of the course, I'll have introduced you to tools and some of the methods that I use in about 90% of the work that I personally do with this software. So, who should take and can take this course? I've specifically designed this course for the absolute beginner, so no previous knowledge of 3D modeling is necessary. I start at the very beginning describing what 3D space and 3D models actually are, and then go from there. So anyone with an interest and desire to learn 3D modeling with some basic computer skills can take this course. Do you need to be a designer in some field to take this course? It won't hurt, but it's not necessary. Most important is a commitment to wanting to learn the material and diving into it with enthusiasm. Like any subject, the more time you put in, the more you will get back. Something that's important to remember is that making mistakes is always a critical part of learning. You can always undo or start a new model, so the stakes are low. And trying things in different ways, experimenting with the things that I show you, creating multiple variations of something, is a big part of working in the digital environment, and why I ask for at least 3 versions of projects in some of the assignments, because I want you to grow accustomed to an iterative way of working. Don't put all your eggs in one basket, my mother used to say. Don't invest everything in one form or one project. Challenge yourself and your assumptions. I hope you enjoy my course, and I will see you in the first lesson. So in this video, I'm going to talk a little bit about the fundamental characteristics of the space that we're going to be working in Rhino. Now, this is not a picture of Rhino. This is a picture of a segment of our universe. But we could think of the space in Rhino as another world, a world that exists on the computer. But in some ways, it's the obverse of our universe. If we think of, our universe and the way that we develop rules and we develop laws based on observation. So let's say, for example, the law of gravity, and we apply that to our understanding of the universe. Well, the space in Rhino works in the complete opposite way. So the rules and laws sort of come before we create that space, which is to say that that space is completely derived mathematically. So it's the fundamental aspects of it are mathematical. Now we can ultimately, with that environment, simulate something like a natural environment or natural space. We do this through like weather system models. But it's purely mathematical. So if something looks random, it's generated through a random set of numbers. So everything is based on a set of numbers. Now, when you first open Rhino, you're going to get this. This is one of the pictures, one of the viewports that you're going to see. And it's the perspective viewport. And it has something that looks a little bit like a piece of graph paper floating in a gray void. And I find one of the first assumptions that people make about this is that this space is somehow limited by this piece of graph paper, that we can only, model sort of within that environment, within that space. But this space is actually quite a bit larger. So this is a little screen capture showing a zoom in, and I created that little box just to talk about scale. And then zooming way back out. So this space is actually quite vast, and the limits of it are really determined probably more by computing power than something that you could make that would fill that space. And it really goes in all directions, in both a positive and negative, up and down. It continues for quite a while. So there's plenty of space, and we can also expand this grid. We can expand our working surface. One of the unique things about this world is that it has an absolute center, which we call the origin. And that center has 3 values, 0, 0, 0, which are its x, y, z values. And this is part of what's called the world coordinate system. So we're really thinking of this environment as a kind of world. Sometimes we give it other names. We might call it a global coordinate system, or something you might have heard of before, a Cartesian system, or Cartesian coordinate system. What that means is that every point, every position within this environment can be located according to that coordinate system. And so that's a very elemental fact of this kind of space. Now that grid, that piece of graph paper has a very particular name. We call it the construction plane, or we frequently refer to it as the C-plane. And that's the plane upon which we really create all of our geometry. So it's the plane upon which we're going to, draw things. We're going to, model solid forms and boxes and etc. It's a very, very important plane, and the control of that plane within the space is a very important aspect of learning to model. Now, from that center, world coordinate center, these values, three values, our XYZ values, are created in both a positive and negative direction from that center origin point. So, for example, if I have a point in space, which I call 1270, it's 12 units along the x-axis here, and 7 units along the y-axis. And because it's sitting flat in that plane, it doesn't have any z dimension to it. But I still have assigned it a z value, in this case 0. If my point is 578, again, 5 along the x-axis, 7 along the y, and 8 along the z-axis. And this can also, again, be in negative directions. When I'm creating an object in space, what I'm really doing is locating a series of points in this XYZ, in this coordinate system, to define that object. So in this case, a 10 by 10 box that I'm drawing from the origin 0, 0 has its most extreme point at 10, 10, 10. Now, where did this Cartesian system come from? It didn't sort of drop from outer space, and it wasn't something invented by the engineers of Rhino. And it's actually quite an old system. The mathematician and philosopher René Descartes he wasn't the first one to use it, but he was the first one to publish a treatise which talked about this Cartesian system, and it really revolutionized mathematics at the time. A number of other people had been working on similar things, and it's interesting to think about that. Something that we use in contemporary that we think of as very high technology actually has this is based on this very sort of old system and old history coming from the Renaissance. And there's other parts to that history that influence the system that we use in the computer. So the system of perspective, which produces the view of our models within the viewport, is actually based on something else from the Renaissance. And this is Albrecht Dürer's Man Drawing a Lute, which is showing these two men creating an image of a lute using a perspectival system which maps points in space. And so this lute drawing here is really this screen is really analogous to our computer screen. Now, we could do an entire course just on perspective. And do we need to know how to construct perspective to be able to do the work in this course? We don't. The computer is actually doing everything for us. And in some ways, the computer, Rhino is a kind of like perfect Renaissance machine. It's creating the perspective. It's locating all the points for us. It does those things automatically. So we can imagine these two men have been replicated within the computer, and that system operates in real time continuously as we view things in perspective on the computer. Now, perspective is one form that we look at objects within that space. And that's a form in which if we drew sort of lines from those objects, they would diminish to some point in space. There's another type of viewing type that we also use on the computer, and that's called orthographic. It has a couple different names. We might call it orthographic, which essentially means 90 degrees. We might call it parallel or isometric. Isometric is a sort of another form of orthographic projection. And these are, the top one is an orthographic projection view of the same exact cube that I'm looking at in the lower view. In the perspective, the geometry of it, if it extends into space, those points diminish at some point. So it's creating a sort of simulation of a perspective like I would see, something in actuality. Where a parallel projection, those lines never converge. So that's one way to remember it, is the lines drawn from an object always extend sort of forever into space without converging. And we're going to look at these two things in much closer detail when we actually use the interface. Now, in addition to Descartes and Dürer, there were other artists and architects working at the time on the same problem of how do you take an object that you have in space, and how do you translate that into another form? How do you duplicate it? And so the architect Alberti worked on this quite a bit, and actually he had a very problematic relationship with drawing, and particularly perspective drawing. He felt it was a kind of gave a false sense of space, and he wanted to reduce objects to really a series of points in space. And so he has this device called the finitorium, which locates things through a kind of radial and extensive point positioning. Piero della Francesca was also doing a sort of similar thing with kind of mapping the human body into slices. And so this isn't perspective. This is they're trying to measure things in a very in an orthographic way to find these particular points in space. And again, these things are kind of mapped onto these systems that we use today. So what we're looking at here is a sort of model in Rhino, and we get these views, this right view, front view, and top view. These are orthographic projections, and we're kind of looking at a diagram which describes how from a 3D model, a 3D spatial model, that information from that model is projected onto those viewports. And what we actually see in Rhino are these different views. So we have here a sort of combination of those views. We have a perspective view, and then we have three orthographic views, a top, a front, and a right. And those views are really described here in this diagram. They're talking about the sort of projection of that geometry in space. And we're going to work with this issue a lot of these orthographic and perspective projections when we get into the software. One last thing is that this C-plane, this surface upon which we construct all of our geometry, is not a fixed entity. The origin, the center of our world, that always stays the same. But this C-plane is actually a mobile thing. I can take it, I can put it on other objects, I can move it to different positions in space, and I can create something what's called a local coordinate system, which allows me to produce objects sort of anywhere within that space. Another aspect, or one last aspect of the viewport, is the fact that I can view things in different styles, and I can output them in different styles. So these are just a few of the viewing types that we'll use. There's quite a bit more. There's at least a dozen viewing types. And we use them for all different purposes, whether we're going to output something or whether we're working on a particular kind of model or we're working on something as a drawing. We will be able to switch between these things pretty fluidly. So in the next video, I'm going to talk a little bit more about what are these objects that we produce within this space. So in this video, I'm going to discuss a little bit the types of objects that we're going to create and what really defines a 3D object in this environment in Rhino. Now, this is a much broader discussion. This is actually a discussion that we're going to have throughout the entire course because we're going to be talking about geometry in its different aspects, points and curves and surfaces. And this is just the beginning of that conversation. We're going to go back over a lot of these things quite often throughout the course. We're going to sort of build on this. So this is a basic introduction to sort of what a 3D object is. From the last lecture, I showed this 10 by 10 by 10 box, which is a 3D object in space. It's what's called a solid object. It's made with surfaces. There's an interesting sort of phenomena if we talk about something as a kind of solid object. What exactly does that mean? Because if I do something like explode the box and I pull a surface off of it, I see that there's nothing inside the box, and that the box is actually made up of these things called surfaces. And what we're looking at, these sort of lines on the surface, are called isocurves that show the kind of directionality of the surface. These surfaces have no dimension to them, which means they have no thickness. So they have a dimension in sort of length and width, or what we'll ultimately understand as U and V distances. But they have no thickness. That in order to give something thickness, we actually have to construct it with other surfaces. That's a sort of characteristic, or an essential characteristic, of working with surfaces in Rhino. Now, when we call something a solid object, what exactly does that mean if the thing is made up of these surfaces that have no dimension? Well, a solid object, in order for an object to be solid, it has to be made up of multiple surfaces, and they have to be joined together into something that's called a polysurface. Now, the prefix poly, all that means is many. So if we think of polygons, are shapes with many sides. And so a polysurface is simply an object that we create that's made up of multiple surfaces that are joined together. Now, I can have a polysurface that's actually not closed. It's not a solid object. It doesn't sort of close back on itself. In order for something to be a solid closed object, it has to have no gaps in it. So it can't have any openings in it. So here's a sort of visual description of those things. So the first one is a cube with 6 sides. It doesn't have any gaps in it. The second one, I take the cube and I cut a window in it, and that's no longer a solid object because it has this essentially a hole in it. Same with the second one, where I take the corner out. And the third one, I sort of fill in that corner with surfaces, and it makes it a closed object again. Sometimes it's actually very difficult to tell whether or not an object is completely closed or not. That you could have a very, very slight gap between surfaces, and it's not going to make what's called a closed or well-formed object. So there's a really great tool in Rhino called what. We just type what in the command line and we hit enter after we select an object, and it gives us a whole bunch of information about that object. And so that's the way you can tell absolutely if something is a closed object, because it will tell you within this dialog box whether or not it's closed, and it'll give you a whole bunch of other information about the object too. Also, how many surfaces it's composed of and what its ID number is, and a whole bunch of other information. I select this next object, and it tells me definitively that it's an open polysurface. It's made up of multiple surfaces joined together, but it's not closed, so it's an open. And why this open-close is important is because through the first couple of assignments, we're going to just be working with closed, solid objects. These are some of the objects that we're going to be working with. So we're going to work with a single palette. All the objects that we'll create will be accessible within that palette. It's a palette called Solid Creation. You can create solid objects of all different sizes and shapes with that, and we're going to be doing the first couple of assignments just using that one palette and a couple of other tools. I would be remiss if I didn't talk a little bit about some of the other geometric types that are in Rhino. I've been talking about surfaces, and when I talk about surface, what I'm referring to is a NURB surface, and I'll talk about what the acronym means in a minute, what it's referencing to. And then there's something else called a mesh. And then if you're working with the most recent version of Rhino, there's something called sub-D. Now in this course, since this is just an introductory course, we're just going to focus on the NURB surface. We're not going to get into meshes and sub-Ds, although you should know of their existence and a little bit about their qualities. Why we focus on the NURB surface is because that's really what Rhino was designed around doing, is working with NURB surfaces, and all the really best tools and all the way the program is designed is to work with those types of surfaces. A mesh is actually one of the simplest forms of geometry that we have. It's simply defined by points in space. A NURB is a little bit more complicated, and we'll get into that. But with a mesh, all the faces are flat. Even if you have something called a quad face, which is defined by 4 points, it's still a flat face. And meshes are important if we're doing something like outputting some geometry for 3D printing. We'll have to translate it into a mesh. Sub-D creates very curvy surfaces, and it's usually derived from a mesh. You can see in these two images the kind of translation, and so a sub-D has what's called a kind of control lattice, right, which is made up of these points, and that control lattice is a kind of ghost of the original mesh that it was produced from. And you can see that its faces are determined by, the sort of translation of these faces from the mesh into that. So it's a very, very interesting type of geometry. If you advance within Rhino, you're really going to want to get into that, especially if you get into making very sort of curvy type surfaces. We can translate from a sub-D back into a mesh, and when we do that, the curvature of that surface, because meshes are always made up of flat surfaces, or flat faces, I should say, that if we want it to be smoother, we actually have to have more faces to create smoothness in form, and that the number of faces within a mesh really alters the characteristics of that form that's produced. So our focus is really, in the course, is really going to be on this thing called a NURB surface. What that stands for is something, it's a much longer name, non-uniform rational B-spline. I'll get into exactly what that means in a later lecture. And we like to call them NURBs because it's close to nerd, and so it's easy to remember, easy to say. A surface, a NURB surface also has something like the sub-D, has a kind of control lattice, and that might have points that coincide with the surface, or they might be sort of out in space off of the surface. And in lesson 3, we're going to get more into how we manipulate and produce surfaces and edit them based on those points, because we can stretch and pull and alter surfaces in really a lot of different and very interesting ways, and we will be getting to that ultimately. So in this video, I'm going to give you a brief introduction to the different parts of the user interface. I'm not going to tell you every single thing about it because that would just be confusing. So I'm going to give you a kind of general lay of the land. And the thing to keep in mind is that we're going to be using the interface throughout this course, and you're going to be introduced to different aspects of it in different parts of the course, and these things will build on each other as we go. And so a lot of this stuff is going to be redundant. We're going to go over it again and again. We're going to use it in individual videos. One thing I should say, if you're using a Mac, that I use a PC, and I'm going to be using the PC interface. So the Mac interface, if you're using that on Rhino, it's going to be different. Things are going to be in different parts, different locations. So either you're going to have to make that translation because I can't use two interfaces at once. You're going to have to make that translation, or what I recommend is you use something like Boot Camp. I don't recommend Parallels, but if you use Boot Camp to boot your Mac as a PC for the duration of the course, so you're using the same interface, so you'll get the same look. That's what I can recommend. So the user interface, sort of the main parts of it, when you open it, it's going to look like this. We're going to have 4 parts to our viewport. We're going to have a perspective, top view, front view, and right view. And to the right, you're going to have layers and view properties. This properties will go to object properties if I have an object selected. Those are the two we need to worry about. All the way to the left, we have a sidebar that has a bunch of different tools. This sidebar will change if I select a different tab. So for example here, if I select Solid Tools tab, it's going to change this sidebar and this top bar. If I go back to standard here. Now generally we're going to leave it in, our tab is going to be standard and our sidebar is going to look like this. Generally we won't use these tabs, and I'll talk about that a little bit more in a second. Down at the bottom of the screen is our status bar, where we do things like control our snapping, object snapping, and gumball. All the way up at the top are our pull-down menus, and these look a lot like standard menus that you would have in any other program, such as Word. This is where you create new files or open an existing file, or do your saving. This is also where we're going to print when we want to produce images of our work. We will use print to print them out here. Under Edit, we have our typical undos and redos, cut, copy, and paste, and delete. They all work also with the same key commands that you might find within a Word program like Control X and Control V. Now, one of the things that can be a bit daunting with starting a modeling program like this is the kind of overabundance of tools and options that you'll find within the window. And something to say about it, well, there's one thing, which is that there's actually a lot of redundancy within the program, that you have a lot of the same tools in different locations, so it makes it seem like there's so much more. So for example, if I want to create a box, I can go over here to the side tool palette, click on box, and if we just sort of draw on the scene, I can create a box. Now I can do that same exact thing in a couple different ways. If I go to my solid tools here, I also have the same tool box here. If I go up to my pull-down menus, I have solid and box right here. So all of those are the same tools. The other thing I can do, and another part of the interface I'll point out, is our command line, which is a very important part of the interface because it really tells us what's going on with the current tool or current situation. So when I select box here, I'll see it comes up within the command line, and I have a number of parameters related to the box. And we're going to do a whole video on creating solid objects, so we don't need to worry about that now. If I want to get out of anything I'm doing within the command line currently, I just hit escape and it allows me out of that. So the other thing I can do in the command line is if I type in box, I get access to that same tool. So again, there's a lot of sort of redundancy in these parts throughout the interface, and really we're going to be using a sort of fraction of those things, and we'll make very clear what tools you'll need to do the assignment that we're asking you to do at that current moment, and these things will build on each other throughout the term. So your interface is, really we're going to use it in this configuration where we have standard. This gives us access to some navigation tools here and some of our options, and then gives us our sort of standard toolbar of tools. Now, if we look at our viewports for a second, we're given these 4 default viewports: perspectives, top, front, and right. And you can enlarge these by double-clicking on the name. So if I wanted to go full screen to perspective, I would double-click on it. If I want to go back to the 4 part, I would double-click on the name again. And I can do that for any viewport. If we enlarge perspective, and so we use mouse navigation quite a bit in Rhino, and so if we have a left and a right click mouse, which really is necessary for mouse navigation, if I'm in the perspective viewport, if I right click, I can do a view sort of arc rotate. If I right click and hold the shift key down, it allows me to do a pan. If I right click and I hold the control key down, it'll zoom in and out. If you have a scroll wheel, you can use the scroll wheel to zoom in and out. Now with my orthogonal views, like top, front, and right, if I enlarge those, if I right click, I don't do the rotate view, I just pan. And then control will allow me to zoom in and out. In the next video, I'm going to talk very specifically about our C-plane, construction plane, and our viewports, and the way that we use those. So I'm going to go into that in some detail. You can also use, navigation tools up here. I can select rotate view. And a lot of the tools you'll notice have this little icon below them that has a left click and a right click. Like this control points on and off, right click off, and show control points, left click on. Hide and show objects is the same. So that's what that little icon means. Now, another thing you can do with any of these, if they have a little triangle associated with them, it means they have a flyout. So if I click on that little triangle, I have access to a whole bunch of other tools. So this is my solid tools, and I can pull that palette out. And if I'm, let's say, using solid tools quite a bit, I can position that somewhere in the screen. I can also dock it somewhere. I can undock it, and I can close it. It's not going to disappear forever. It always goes back to its original, or it exists in its original position. I can do the same thing for my palettes over here. These can be pulled off and docked, or they can be put back in place and organized. So I like to do a couple things to set up my interface. So my C-planes, which are up here, I like to pull that palette out since I use those quite a bit, and I dock them down at the bottom here. Because we're going to access these tools quite a bit, so I like to have them present. The other thing I like to do is turn my grid snaps on and turn my gumball on, because I use those quite frequently. And then the last thing I do is I'll go under my options, and this is going to sort of look like this when you open it up. If I go under View, and under Ghosted, which is a view type I like to use a lot, click on that, and then go under Backface Settings here, and single color for all backfaces, and I set my single backface color, clicking on that, to something like purple, something pretty garish, and hit OK. Under visibility too, I also turn off my ISO curves. Now, this is not going to make a lot of sense to you, backfaces and ISO curves. We're going to talk about that a lot when we get into talking about surfaces. But just like to set things up in this way. So what I'm working with is going to have the same appearance as to what you're working with. And so there will be some correlation between those things. The other view type that I like to change here is shaded. I'll also turn off show ISO curves here, and then just hit OK. And so that's about it for setting up our interface. In the next video, I'm going to get into our viewports and the C-plane. There's not a lack of information about Rhino you'll find on the web. There's a lot of different sources for finding tutorials and different information about modeling in the program. What I want to do in this video is point out specifically some of the sources and the areas that you're going to be using that are going to pertain directly to some of the material that we'll go over in this course, what's going to be helpful. So if you go into the interface and up under the pull down help, you'll see a bunch of topics, learn Rhino, help on the web. Most of these linked to like frequently asked questions. They'll linked to the McNeil site, which is the company that produces Rhino. The important one for us here is if we go under Learn Rhino to tutorials on the web, that'll open a site at McNeil called rhino3d.com. Learn, and that has a bunch of different tutorials and things you could go through outside of this course. The most important document here, though, for us is this user's guide. So this is an online user's guide. If I open that up, the first page, the introduction, goes through the interface, some stuff I've covered or will cover. So it's a really good reference, and then we also reference these in any of the assignments. We'll reference sections of this with direct links to it, or from any of the videos that are specifically, let's say talking about selecting objects. So you'll be able to go through some of this text-based stuff after the videos if you need to cover some of that material again in a different form. Now there's also a really handy help here over in the palettes. If I open that, there's a bunch of topics here which link to some of the same videos and some of that same material through that web, and it's a bit daunting because there's a lot of different material and different subjects, and it's not so, this isn't so useful. I don't find it so useful in that way, but how I do find it useful is if I click on, let's say we're going to make a box, and I click on that, we'll see that this changes to a help menu, which talks specifically about that tool that I have selected, and a lot of them show me a little animation of how it works and some of the other parameters and ways that you can go about creating a box. So that's super useful if you're just learning to use the tools, and particularly with some tools that require multiple steps. We'll get into some of the Boolean tools which require multiple steps, and it's a quick way of referencing help. The only thing that I find a little problematic about it is that you can't. It's not easy to go back. There's no back button to get to that main menu, and actually to get to the main menu you got to click on something else like object properties here, and then go back to the help, which sort of resets it. That's the only drawback to it. But so those are the two sources. This tutorials on the web. Another way to access that, if you went sort of right to this Rhino website, that's going to bring up the main website, and then you just need to click on Learn, and that's going to bring you to that same exact location. And again, we'll reference these URLs in any documentation where we want to connect you to that information. So I hope that helps with finding some help beyond the material that you're getting in the course. So to begin with, I'm going to reset my screen. I've been playing around with it a little bit, and to do that I'm going to go up to File and New. No, I don't want to save changes, and I'm going to select small objects in millimeters as my default unit setup. And that's going to reset my screen. So anytime you want to do that, you can do that. One thing you'll notice though is that because I set my C-plane palette up down here at the bottom and have my grid snap and my gumball on, those things are still active even though I've started a new file. So it'll leave those things in place when you start new files. So in this video I'm going to talk a little bit about our viewports and C-planes, our construction plane, and the relationship between those things, which is a really important thing to understand, and really what our first series of lessons are about, is really getting a grasp on what that relationship is and what exactly is this 3D space that we're working in, some of the things I talked about within the lecture. So one of the things we're going to need to know is how to create a basic line or shape, just as for demonstration purposes within this video. And I'm going to double click on my perspective window and can use my mouse navigation to zoom around in a little bit. And I'm going to just create a rectangle. So to create a rectangle, and it tells me right below what I need to do, I just need to left click to select it. And then my command line is telling me to click in the screen for the first corner of my rectangle and then draw my mouse out and then click again to end it. So now I have created a rectangle. Now the reason I need to do that is because I want to talk about this thing that looks like a piece of graph paper in my scene, and that's my C-plane or my construction plane. And we know from from the lecture I talked about how the center of this construction plane, this point, is our 0, 0, 0 point of our world, and that's related to our x-axis, which is represented by this red line, the y-axis, which is that green line, and then there's an invisible axis, which is our z-axis, which moves straight up and down. And these around that center point, the center point of our world, they move in a positive direction up and to the right, or a negative direction from there to the left and down, and then up and down for our z. So our C-plane is the plane upon which we construct all of our geometry. And it's going to appear sort of fixed at first, and we're going to use it in a kind of in its default sort of fixed relationships, but it's actually quite a movable plane, and we'll see that in later lessons, how we can move it around to create different things in space. But mainly what we're going to be doing is creating objects on it and then moving those objects around on it, sliding around on it, and up and down in the z direction. Now, if I go back, if I double click on my perspective, and we go back and we have our combination of both orthogonal views, our top, front, and our right, and our perspective view. And there is a correlation between these things. But I'll notice that when I look in my top view, for example, my C-plane, I'm no longer viewing it in this sort of diminished perspectival way, but I'm viewing it dead on. If I zoom out, I'll see I'm looking straight down on that C-plane. And now, actually, if I draw my rectangle here on that C-plane, I'll see simultaneously within my perspective window that I'm drawing actually on that C-plane. If I arc rotate, I can see that I drew on that. So in my top view, essentially what I'm doing is looking straight down on that same exact C-plane. And there's a couple things that give me a little hint as to that correlation between the viewport and the C-plane. So one of them is this icon in the lower left, and that's showing me this Y and this X, and that correlates to the position of my axes on the C-plane and the orientation relative to the viewport that I'm looking through. So the top view has this Y and X correlation. Now if I look at my other views, my front view and my right view, I noticed that icon is not showing a Y and an X, but it's showing a Z and an X. And my right view is showing a Z and a Y. Now what that means is that if I were to, and I'm looking at something which is looks quite similar to my top view, right? I'm looking at a C-plane dead on. Now, but if I draw my rectangle in there, watch what happens in the perspective viewport up here as I draw. It draws that rectangle in space. So the plane that I'm looking at, this C-plane for the front view, is actually a plane which lies along this x-axis and is a vertical plane along the z-axis. So in this case, in the front view, the green here is not representing the y-axis anymore, but it's representing the z-axis. And I can tell that because from this little icon down here. And on my right view, if I draw another rectangle, you can probably already guess where that's going to show up. Okay, it shows up there. So in this case, the red is my y-axis, which is that axis, and the z is straight up and down. So I'm drawing that rectangle along that axis. Now, there's a different way that we can do this. And you can also see here too that I see a sort of dark line here along that plane. So if I click on that, I'm actually clicking on that rectangle, right? So I'm seeing the edge of that rectangle in space. And this line is the line of that C-plane in my perspective. So it can be a bit confusing at first because I'm looking at sort of multiple C-planes really. This one, the top view, happens to match up with this one, but these two represent sort of different different C-planes, different positions of different C-planes. So that can be a little bit confusing at first, but you'll get used to it. Now, one thing I can point out here, if we enlarge our perspective, and I have my C-plane palette down here, which is a very important palette, and we're just going to worry about these 6 default C-plane positions to the right here. These are the ones that we're going to use the most at first, and these are giving my positions. So if I wanted to, there's one that's set C-plane world to front. If I click on that while I'm in the perspective view, it's going to tilt that C-plane up to match that front view. Now I can draw, and automatically that rectangle is going to snap to that C-plane. It's going to be drawn on that plane. And then I can switch back here to my top, right? So I can draw that rectangle either using my sort of front orthogonal view, or I can just work in the perspective view and I can move my C-plane around and use that to draw in those different positions. And frankly, the way that I will use the viewports a lot is I don't tend to use them in this sort of quadrant, mainly because I have a small screen. You might have a small screen too, and so it can be difficult to work in sort of simultaneous screens at once. So I tend to sort of work in either my perspective screen or if I'm doing a lot of like drafting type things, I might work within my top view. So perspective, we're viewing in perspective. I talked a little bit about the difference between orthogonal views and perspective views. If I'm in the top view, we know that I can't sort of arc rotate with my right mouse button like I can in perspective. However, if I'm in the top view and I select rotate view, I can then, using my left mouse button, because I have that tool selected, I can rotate into that that view, which is now what's called a parallel view, right? My lines aren't diminishing, and I could, work in this view where everything's visibly sort of measurable in a straight line projection. It's not diminishing like it does within a perspective projection. This is also called an axisymmetric view. Now there's another way that I can set this view, or let's say, for example, if I wanted to reset my top view to its original position, the best way to do that is to go to my flyout. So every viewport is going to have a flyout where I select the viewing type, and then I can also go back to my default position. And so that's typically the way I do it. Now I could also, if I wanted to go into a parallel position, like an axisymmetric or isometric position, I could select that and it would bring me to that same position which I got to when I did my rotation here away from my top view. So those are essentially the same thing, the same type of view. It just sort of continues to call that my top view. So that's a little bit of an introduction to our viewports and our C-plane. I'll talk more about our sort of viewing types when we get into creating objects. So in this video, I'm going to show you a very handy tool called the gumball, and I'm going to talk a little bit about how we use it to move objects around, to copy objects, to rotate objects. Again, it's a very handy tool, and then in order to do that, you're going to have to know something about selecting objects, how to select them, and also to deselect them, and there's a number of different ways to do that. So first thing, I'm going to need some objects to select and deselect, and we know from the last video we know how to, at least how to create a rectangle, and so I'm going to do that on my C-plane in the perspective window here, and I just left click once and then left click to end. Now there's a handy thing. If I've just used a tool, I can either hit enter or hit the right mouse button, which amounts to hitting enter. And what's going to happen if I watch in the command line, it's going to select, or it's going to activate that tool that I just used. And so this allows me to, when I right click again, allows me to create things pretty quickly if I want to use the same tool over and over again. So that's pretty nice. Okay, and so I have a bunch of objects here, and so how do I select them? Well, the simplest way to select an object is just to click on it. So if I'm just selecting one object at a time, and I can see my grid snap and my gumball are active down here. And actually, if I deactivate the gumball just while I'm talking about selection here, I'm going to do that. So we'll just deactivate that for a minute. So I'm just going to select the object, and it turns yellow, and so I know it's selected. And so that's the simplest way if I want to select sort of one object at a time. If I want to select multiple objects, I can click on them one at a time. If I hold the shift key down, this will allow me to select multiple objects one after another, clicking on them. If I want to deselect any of those objects, I can hold the control key down and click on them, and that will deselect them. Okay, that's fairly straightforward. Now there's another way to go about selecting and deselecting objects using the mouse. And if we shift to our top view, it'll be easier to see from there. So if I hold my left mouse button down while I drag the mouse, you'll see if I do it from the lower left to the upper, or the lower right to the upper left, I get a box that has a dashed outline to it. If I do it the other way, from the upper left to the lower right, I get a outline that is not dashed. And what the dash and the not dashed signify is different types of selection. So if it's a dashed line, any object that I just cross through, I'm going to be able to select. If I have the solid line, any object that's within that box is going to select. If it's outside of the box, then I'm not going to. It's not going to select it. And so this is a very handy tool, especially if I have a sort of collection of objects that I need to select something within. I can, use that box just to cross through them. I don't have to, or if I just wanted to select sort of one object out of these, I could just use that dashed box. And so that'll become really second nature, using those two boxes, those two movements to select things. Now there's other ways to select. If I look up under my edit and under select objects, there's a whole host of different ways here to select. And just a few things I'm going to point out. Let's say, for example, I wanted to select all curves or polylines within the scene, which is what I'm dealing with these rectangular shapes. It's going to select those. And then I could, deselect one. Let's say, hold my control key down again to deselect it. And let's say I wanted to select that one object and not select these others. I wanted to invert my selection. I could go up to edit and select objects and just invert, and it's going to invert that selection. I can also, let's say I had stuff selected and I made a mistake clicking in the scene somewhere, and I wanted to reselect that. You can go to select objects, and it has a previous selection here, and it's going to select that object again. If I want to deselect an object that I have it already selected, all I have to do is click anywhere within the scene. I think you can also hit escape to get out of that. So that's selecting, deselecting objects. So now I'm going to talk a bit about the gumball, and I'm going to delete those, and we'll just deal with one rectangle. So I'm going to turn my gumball on down here, and when I select that object, I say I get a device that has a whole bunch of axes and different rotational elements associated with it, a whole bunch of different, and a little plane icon here. So the gumball is a very useful tool, allows us to do a whole bunch of things. I'm just going to talk about a couple of them that are relevant to the assignment that you're going to be working on. So the first thing it allows you to do is I can move an object after I selected it in a particular direction. And so these red, green, and blue denote our three axes of movement, or X, Y, and Z. And so if I pass the mouse over one, in this case the red one, the X, that allows me to slide the rectangle along that X axis, and it sort of restricts it to that axis. So if I do it along the Y, it does that, and then the Z also. Anytime I've moved something or copied it and I want to undo it, just type Control Z and it's going to go back. You also notice that there's this little what's a little icon of a plane icon, and if I instead select that, you'll see it activates both the X and the Y axes, and it allows me to sort of move that rectangle, kind of slide it around on the X and the Y axes. If I rotate sort of slightly in a different direction, you'll see that that icon disappears and now the ZX one shows up. And that's just because my view orientation has changed, so it responds to that. And it's assuming because of my angle of view, I want to move it in the X and the Z direction. So that allows me to sort of move it around like that, kind of up in the air, and slide it, you know, in the X and the Z. And the same thing would be true about the Y and the Z. You can see that that one's active. So this also holds true not only for the here I'm in the top view, but also in perspective view or straight on orthogonal views. I can select that and I can move in a orthogonal direction from those viewpoints. And this is going to come in very handy for your assignment where you're going to be moving around solid objects, and you're going to want to move them in a very particular specific direction. And that's going to give you a good idea of actually where they are in space. Now, if I want to copy an object, all I have to do is hold the Alt key down while I move it, and that allows me to produce a copy. I can select multiple objects at once, and this allows me to move them. So you can see the gumball always shifts to the center of my selection. And if I hold the Alt key down again, I can copy multiple objects. Select those, and we'll see the gumball sits in the center of those. The other thing I can do with the gumball is I can rotate objects. So these are my different axes of rotation. So the blue one allows me to rotate it around the selected objects around the Z-axis. And actually, if I hold the Shift key down while I do that, it's going to rotate them in sort of 90 degrees. And when I deselect and then reselect them, you can see it kind of reorients the gumball sort of back to its alignment with the world coordinate system. I can rotate this in the y-axis. So you can see it's an incredibly versatile tool, you know, and allows you to, holding the Alt key down, I can produce copies of things, and allows you to produce copies of things really quite quickly. I can do that too while I'm if I'm rotating, holding the Alt key down. Yeah, there we go. So really allows you to very quickly sort of produce duplicates of things. And what you're really going to want to do after this video is just, you know, make a rectangle and start experimenting with the gumball tool to get used to it. You're going to be using it a lot throughout the course, and particularly in these first couple lessons. Okay, so now we're going to actually make some 3D geometry. It's very exciting. And what we want to do first is we want to create a new file so we know we're working in the right units. So I'm going to select small objects millimeters down at the bottom, and that resets our screen. And then down at the bottom of our screen, I want to select grid snap and gumball. Now, I haven't talked too much about grid snap. We've just sort of had it on, and if you go to your perspective window and double click, I can show you when I draw a rectangle that, and even as I just move the mouse around, you can see that what it's doing is it's snaps to those different points of the grid. Because the units I'm working in, those are millimeters, and what this also, as I move this around, sort of in the screen, if you look down, all the way down at the bottom of my screen in the lower left-hand corner where it says C-plane, I have an X and a Y and ultimately a Z value. It shows me the units that I'm working in millimeters. But if you look at that area of the screen while I move my mouse around, you'll see that how my X and Y are changing. So it's showing me the X and Y position relative to the world coordinate grid. It's showing me the square it's snapping to. So if I move this all the way to the origin, you can see that down at the bottom my X and Y are 0 and 0. So if I wanted to draw a rectangle that was exactly 10 by 10, I would start there and then drag out. And because my grid snaps are on, it's snapping to that. And then I can see down at the bottom my X and my Y are 10 and 10. So that means I'm creating a rectangle that's 10 by 10. So for this first assignment, and then when we create these solid objects, we're going to want to leave our grid snap on because we want to create them to a precise size, because that's how the assignment is going to work, because everything has to sort of fit together kind of like a puzzle, so they should be of that precise size. So all we really have to do is keep an eye on that, my lower left hand corner when I'm creating things. I'm going to create all my objects at the origin, and that'll give me control over their sizes, and I'll just leave my grid snap on. Okay, so we're going to create some solid objects, and those are the things that we're going to use in this lesson. And to do that, I'm going to pull out my palette of my solid objects. So here it says Cascade Solid Creation. And once that's open, I can just pull that palette off, and then it's going to be fixed in the screen. So the first thing I'm going to make is a box. And first base of the corner I'm going to put on the origin, and then my second mouse click defines the other edge, so that's a 10 by 10 at its base. And then I'm going to look, if you look down at the bottom, you'll see the Z dimension, and as I drag up, that Z dimension increases, and so it's also snapping to the millimeter in the Z direction also, and that allows me to create a 10 by 10 box or volume. Now I haven't talked about our viewing styles yet, and because we haven't created any solid surface geometry yet, so we haven't really noticed a difference. But under any window that I'm working in, viewport that I'm working in that flyout, all the way at the top are my different viewing styles. And by default, you're probably working in wireframe. Now, I will tell you what I typically work in, and everybody's going to have their own style, but what I would like to work in is ghosted. And then I'll sometimes go to shaded or rendered when I go to output an image, or I could also do it in ghosted. Why I choose ghosted is because it allows me to see the exterior of an object and the interior at the same time. And it gives a nice sort of definition to the edges of objects. And because I've set my back face to that purple color, I get this nice sort of lavender appearance in it, and it helps the object sort of read really well. You can select, if I select shaded, so that's going to give me a sort of solid view with hard edges. Rendered is going to give you a rendered sort of shadowed view. It's not really a useful way of working in, because it becomes difficult to sort of see objects in that. So typically I'm working in either wireframe shaded or ghosted, and you can experiment with these others. We might talk about some more later, but those are typically the ones I use most, and most often I'm working in ghosted, particularly when I'm working with solid objects. So if I create that object, and this is how you're going to create your standard objects for the assignment. You're going to create them, and then you're going to sort of move them out of the way, and then create the next one. So if I create another box, and this one we could make, looking down at my Z, I'm going to make 20 millimeters high, and you can see it's pretty easy to make those things. And I could do the same with, let's say, making I might want to make a cone. That gets made from the inside out. So I'm gonna, if I want to make it 10 millimeters in diameter, its radius, which it's measuring now, is going to be 5, and we can see that X value down at the bottom down here is 5. And then I can see, my Z value, maybe I'll bring it up to like 30. Okay, and I'm going to work within those whole values. Now, something like, some of these are going to be different, and you notice when I create a box that there's a bunch of different ways that I can create a box, and that's essentially what these are referring to. Whether you want to do it from, see, I have first corner of the base, but I could do it from the center, right, if I wanted to. That's what those parameters allow me to do. If I choose something like the truncated cone, and this is where my parameters get a little bit more significant in my command line, because if I use the truncated cone, I'm going to have to decide a couple things. So it's telling me what it's going to do by default, and of particular importance are these first two. So direction constraint. It doesn't have, it's saying none, so it's not going to constrain the direction that I extrude that cone to vertical like this cone did. So it's probably going to snap it to the plane, or the C plane, and then it's also not going to make it solid. So let's just try that and see what it does at first. So it allows me to make that base circle just fine. But now we see what that, and if I rotate this a little bit, we see the end is snapping, right, to the C plane. And then the second or third click at this point, it determines my top of my cone, the width. And now, because I had it solid at no, it doesn't make a solid object. So I don't want that. I want to make a solid truncated cone that's vertical. And so how do I do that? So I'm going to select truncated cone again, and I'm going to choose my direction constraint. So I can click on that, and I'm going to choose vertical. And then for solid, I'm going to click on that, and it switches it to yes, from no to yes. So now it's telling me it's going to be vertical, and it's yes, it's going to be solid, because I want to use only solid objects in these first exercises. So X is 5, and then we can go up to 20. And now I have a truncated cone. Okay, so there's a list of objects that you're gonna create for this first assignment. Certain box sizes, they're all specified in the assignment. Pyramidal cones, truncated pyramid. It lists those, and you can, again, using your gumball, it's going to be easy to duplicate those things. So you really only have to create one type once, and then holding your Alt key down, you'd be able to duplicate these things pretty quickly. So you can get the numbers up pretty fast. You don't have to generate each one separately. Now there's one last thing. I use my arc rotate, and we notice my arc rotate is sort of rotating around the sort of center of my viewpoint here. What if I had an object, and you might end up with objects that are like all the way over here, and I want to rotate around that object. This makes it very difficult because it's sort of rotating around some arbitrary point. If I want to rotate or change the center of my rotation, all I have to do is select the object and then select my zoom selected, and that's going to zoom me right in on that object. Now my arc rotate goes around that object. If we zoom back out, so I can change that again, like if my truncated cone, I can do zoom selected, and now I'm rotating around my truncated cone, which makes it really easy to sort of navigate that space. So that's solid object creation. Next we're going to look specifically at what you're going to be doing with these objects for the assignment. So in this video, I'm going to talk specifically about the assignment that you're going to be doing, and show some examples, but also talk a little bit about why we're doing this assignment, what the history of it is, and because it might seem a little strange relative to a course in 3D modeling. But it actually has a quite interesting history in relation to the development of design. So the first thing that you're asked to do in the assignment is to create this selection of solid modeled building blocks. And we specify very particular dimensions within the assignment. And that's with a reason, because we want sort of proportional relationships between these objects, which are going to affect how we can actually put them together. So they can't just be anything, although there should be enough objects and enough different types that allow for a pretty big range of experimentation. And I think you're probably going to find that you end up using a fewer number of different types than every single one. Now, this might conjure up memories of playing with wood building blocks or things like Legos, and that's perfectly okay, because we're actually working in relation to that sort of history, the history of the building block toy, and as you did when you might you want to access your inner child, or maybe you are a child taking this course, and you want to sort of let your imagination run a little bit in terms of the things that you can construct from these blocks, and really play around with them within this new space, 3D space. Some of you might also be familiar with things like Minecraft, which the basis of all constructions in Minecraft are this single cube that gets repeated. And so it's not unlike that. I do have a kind of criticism, though, of Minecraft, in that one of the things that it misses is that the sort of variation within the unit sets up interesting proportional relationships between objects. And the fact that if we just use sort of one type of unit, it doesn't allow for these sort of gaps and shifts between different different parts. So these are a few of my experiments, and I'm going to show these more in the tutorial, the software tutorial, and we'll actually look at them, a couple examples within 3D space, and I'll run through a whole process. But I think that these proportional relationships really foster a kind of unified compositions, that they're not just about a sort of random configuration of blocks. That's not what we're looking for. Now, there's a very, very fascinating history related to the use of blocks in education. And there's this gentleman by the name of Froebel, Frederick Froebel, from the 19th century. He was actually the originator of the kindergarten, and he created this series of things called GIFs, which started with actually very simple sort of paper forms and ultimately got to blocks. We can look at the illustration of the child in the middle of this image is playing with blocks on a gridded table, which sort of controls the position of the blocks, not unlike our gridded construction plane that we're going to be working on. This education system and the use of these GIFs actually had a really profound influence over many designers throughout the 20th century and even today. So on the right, we're looking at images from Frank Lloyd Wright's autobiography, in which he talks at length about his indebtedness to the Froebel system and that the impact that it had on his design. It also influenced other designers like Buckminster Fuller and the Eames. In the links below the video, there's a 99% invisible podcast that you might want to listen to if you're interested in this history that goes through that whole thing. It's a very fascinating story. The other thing that you're going to want to do in this assignment is sort of look around you. Not only you can look on the web, you can Google things, but also look in environments around you for patterned systems that are made up of individual simple elements that create much more complex systems through their aggregation, through their repetition. Those things are all around us. You'll find them in brick patterns, you'll find them in stonework, you'll find them in tile patterns. They're everywhere. So you might want to do a little bit of sort of searching for what your influences in this assignment might be. And we'll have a folder of a whole bunch of examples and things that you can look at too, and also just things from this lecture. There's an interesting research collaborative, Gramazio and Kohler, at the ETH in Zurich that's doing amazing things with robotic construction just using a very simple brick. And so they're clearly this is a pattern that's designed on the computer, which tells the robot where to place it. And guess what? It's just based on an XYZ location. It's just a coordinate that it's locating, that it's positioning that brick in space, and it produces these sort of amazing architectural works. Another fantastic resource, Annie Albers was an artist and educator, taught at the Black Mountain College in North Carolina in the 60s with her husband, painter Joseph Albers. Did this fantastic book called On Weaving, and she's talking about weaving patterns, and she has this wonderful series of diagrams that explore different variations of weaving patterns just using a simple grid. These are great places to start with this project. So I really like this one all the way to the left. At first I thought it was a completely random pattern, but then I noticed Albers' little marks here. And it's actually repeated in sort of quadrants, and you can start to kind of identify these repeated elements within it. And so that was one I decided to sort of base a 3D model on, and I played with it a little bit by shifting the blocks sort of in space to produce some three-dimensional variation. And so you can base your project on, it doesn't have to just completely come out of your head. It could be based on some pattern that you find and build off of. Now, here's another example we're going to share with you. And it's a very good example of, and it's just using one element. So just this cylinder that's 1 unit high. but it's a very good example of what I call a procedural logic to produce a form. And what a procedural logic is essentially a series of steps which typically use a sort of individual element that gets repeated, and through this series of steps you end up producing a form that's much more complex, that's in a sense a whole that's bigger than the number of parts, or more effective than the number of parts. So this diagram is showing that this cylinder just simply gets copied in a line. That line gets rotated, and then that's repeated and then rotated again. And that's it. It's a series of 5 steps, which then produce a pretty complicated form. Another example I'm going to talk about, I'll actually construct something like this within the software tutorial, is again a procedural exercise. It's producing these sort of rows of blocks that get rotated, shifted, rotated again. So we have plenty of examples for you to look at that are make clear this concept of procedural logic. Now, there's this hidden agenda to this problem, and that's that you're going to have to work pretty fluidly between your different types of views. So if you tried to work completely in perspective, you would probably end up with something that you're not so much in control of. So in this perspective view, it looks as if I'm positioning this block next to this other block, but if I actually look at it in the front view, my block is sort of floating out somewhere in space. And so with this exercise, it's going to be very important to use your orthogonal views, use your top view, your front view, your side views, to be able to very specifically position your blocks in space, to be able to copy them exactly where you want them. The perspective view, although you're going to want to look at things in your perspective view spatially, it can be deceiving as to where things actually are. And so that's really an important part of this assignment, is being able to move sort of fluidly between those different windows. So have fun with it, and I look forward to seeing your building block constructions. So in this video, I'm going to run through a sort of similar process that you might be going through with the first assignment, the building block assignment. And I'm just going to point a few things out and run through a few steps. But it's really an assignment that's about sort of experimentation and getting used to using the interface and the gumball and doing some solid object creation. So I'm already working in my millimeters. I have my grid snap on. I have my gumball on. I might have my solid creation palette out so I can create my objects. Now the first thing you might want to do is just sort of create the series of objects that you're going to be working with. You don't necessarily have to work with them all, but you can just start experimenting around with them, which is what I did here. And if it helps to sort of identify, let's say, particular things that you're trying to make, as if you're making something with them as blocks. So in this case, if I make a sort of celebratory gate, over here I'm making a kind of varied wall that has as much open space in it as it does solid space. That was one of my intentions with making that, and it wasn't just a thin wall, it had some depth to it. So it was really more of a kind of sculptural wall. And if you notice too, I'm only using a couple of different blocks. I'm using a 2-block, it's a 3-block, and a single block to do that. Or I might treat 2 blocks as a kind of L shape, and maybe my strategy here is to do a design
that's made out of one continuous line of blocks, and that sort of negotiate each other. And so there might be different through experimentation. You might come up with different themes and systems. And as I talked about in the lecture, ultimately you should try to start to focus on the issues of repetition, of pattern, and variation, and use a kind of procedural logic to produce your final designs. And so I'm asking for 3 different designs, so that should give you enough time and space to experiment. And so with this, the final one I came up with is a kind of tower, or twisting tower, and that uses a pretty tight procedural logic to produce that. And I'm going to go through some initial steps that I did to make something sort of similar to that. Now, a very handy tool when you're working on these things is to be able to hide things and to make them appear again. And so if I want to sort of not delete things, but I want to kind of temporarily get them out of the way, I can select them. Let's say I selected everything here, and go up to this little light bulb and left click it to hide those objects. And then to bring everything back, I could show them. And so that's very handy. You could also just sort of move things out of the way, sliding them off to the side. Again, you can work, the C-plane isn't the limit of your working space. Your working space is actually quite vast. But oftentimes, especially when you're viewing from different orthogonal views, you're going to want to hide things. So I'm going to do that. I'm going to hide these, and I'm going to go through the process of at least beginning to construct that tower. And so that I only used 2 blocks, and I'm going to go change it to my perspective view. Okay, and so I have a single block, which is a 10 by 10 by 10. And then I have a double block, which is a 10 by 20, and I'm going to make it sort of sideways here. Now, something I didn't show when I was doing the selection was that if you have, and you can have geometry, you can have lots of geometry on top of other geometry, that just because these are volumes, it doesn't mean they have they're going to push each other out of the way. They can lay directly on top of each other. If I go to select something and I have multiple geometries on top of each other, I'm going to get a little flyout dialog box window, and it's going to show me, it's going to give me a selection menu, and it's going to allow me to toggle through those things, or select none. It's going to allow me to toggle through those things to select, and it's going to highlight the piece that I'm going to select. Okay, so a big part of this this assignment is going to be moving between your orthogonal and perspective windows to create the design that you believe you're creating. Oftentimes the perspective window can be really deceptive in terms of where things are in space. Your axisymmetric or parallel view window can also be pretty deceptive. So you're going to want to sort of be moving things around in your top view and your front view and your side views, so you know exactly where they're going. So I'm going to go back to my front view here. And so if I want to move this block precisely on top of this other one, and I could view it also from the side, if we go to the right side, I could see that it's not, sort of out of line somewhere. Although maybe I want to like offset this a little bit, sort of punch it out a little bit. So let's try that. It'll give me a little shadow line. So I'm going to go back to my front view. And then I'm going to take those two blocks and I'm going to duplicate them. And because I'm doing this from the front view and my snaps are on, I can do this pretty precisely. Let's do it 5 times. And we can arc rotate out of this so we can get a look at this. And I'm going to push every other block back a little bit so I just start to get some patterning in that surface. View from the top. Yeah, so I'll push this back. That's a little bit more sort of variation within that surface. I'm not going to play with that too much here, but okay. I'm going to select those. I'm going to go back to my top view. And I'm going to duplicate all of those, holding my Alt key down. And then I'm going to rotate them 90 degrees, holding my Shift key down. And then position them. Let's see what that looks like. It's okay. And I'm going to do the same thing again. Go back to my top view. Alt key, copy it, rotate it, holding my Shift key down. And let's do one more. Alt key, rotate. It's not perfect, but it's okay. Okay, so I have my first sort of row of blocks. And now, the logic of that tower was that each successive row sort of rotated a little bit, and that's what produced the twist in the tower. And so the way I did that was to select those first 2 rows and looking at it from my front view, because I want to move it up. I want to actually copy it up very precisely. So I hold my Alt key down. Then I copy it up, and then I keep it selected. Now, for some reason, accidentally unselected it. I can go, and rather than going like this and holding my Shift key down and selecting everything, which would, take forever, you want to use your views to your advantage. So go to your front view, and then use my dashed selection, and then I can just select everything on those 2 rows all at once. Right, so very handy to do that in your orthogonal views. So now I'm going to rotate that row just a little bit. Because my snaps are on, it just rotates a little angle. And then essentially just keep doing that. It's a kind of, again, it's a kind of procedural logic, right? If I take that, copy it, keep it selected, go back to that view, rotate it, back to my front view, copy it, rotate, so on and so forth. You get the idea. And so that's what's meant by a sort of procedural logic, that I go through a sequence, a repeated sequence, which then starts to produce the larger form from these smaller pieces through a sort of sequence of moves. And in some of the in the examples that I showed in the lecture too, and also some of the patterning examples, they're doing that. Like, so one block would shift, one unit as it moves over. And these sort of procedural logic or sequences are going to allow you to produce these sort of larger patterned and varied structures. And that's really what we're looking for in the assignment. And it's also going to force you to move a lot between your perspectival or axonometric views and your orthogonal views. And it's going to get you used to really using the interface. And so experiment with it, try different things out with, each you're asked to do sort of 3 separate ones, and have fun with it. And in the next video, I'm just going to show you how you can output some images from your models. So in this video, I'm going to show you a fairly quick method of being able to output some images from your project. We could have an entire 4-week course just on rendering and dealing with images. So this is the shorthand method, but it will allow you to produce some image work from your modeling files and be able to compile them and post them on the gallery. So one of the first things you need to do before you output anything is actually save your project if you haven't done that so far. And so I'm going to do since I already have this saved, I'm going to save a copy of it. I'm going to do a save as. And one thing you might want to do is create a folder for this course, and then in that folder create other folders for lessons for each week, so you keep everything organized, and then you can keep all of the versions of your models and any other material related to that lesson in that folder. So I'm going to save that file, and then if I'm ready to start outputting some images, the first thing I want to do is decide what style I want to view it in, what viewing style. I'm going to choose ghosted here, so I see a little bit of the inside. And then I'm also you want to choose what type of view. Am I going to view it in perspective, in parallel, and an isometric, which I'm viewing right now? And you could do, I recommend actually doing a combination of those, since you can save a bunch of different images. I'm going to set this to perspective. And what you really have in the viewport is a really amazing camera. It allows you to zoom into things, or I can view things from underground. I can view them from a distance. I can view them from way close up. It's sort of this amazing mobile camera. And remember too that if for some reason the center of your rotation, your view rotation, is somehow thrown off, let's say for example this thing is moved like all the way over there, and I'm still rotating around the same place and not around the object, I need to select this zoom selected, and that'll sort of reset the center of my rotation. So that's a handy feature on it. I'm going to move this back and we'll reset that again. Okay, so if I get it in the position that I want to produce my first image, I'll set it there and go under File and Print. By default, this might look a little bit different when you open it up. I think by default it goes to Rhino PDF, and that will allow you to either put output vector or raster. I'm not going to talk about those differences right now. We're actually going to set this directly to image, so we don't have to make some of those decisions. And I'm going to, all my windows are open here. I'm going to close a couple things. I don't need to worry about margins and position. I don't need to worry about line types. Visibility will keep open, and output and scale will keep open. Okay, so it's set to a landscape 11 by 8.5, which is fine. Printer quality is normal. Since I'm not printing these out, I'm viewing them on a display. I'm going to select display color. So by default, it's going to just print generally what I see in the viewport. If I switched it to extents, it would sort of take whatever's within the scene and zoom in on it from that camera position. I can also select window and hit set, where I sort of select what I want to print based on that final format. Hit enter to return. For this, I'm just going to go with the viewport. You could, if you wanted to, sort of adjust the proportions of that frame. The other thing I need to decide is whether or not I want to see my grid. Do I want to see my axis, and do I want to see that background color that I have set? If I just wanted a white background, I could turn that background color off, and here I can sort of deselect my grid axes. Now, in looking at that, it looks like I'm kind of a little far away. So what I'm going to do, I'm going to close this. It should save all those things that I changed, and I'm going to zoom in a little bit. We'll go back to print. Okay, and so I'm still seeing my preview. So then I just hit, when everything looks good, I just hit print, and I look for that folder I'm going to save it to, and we can just give it a name, image 01. And then I can open this up. And we see it's there. All right. And you can continue. You can save as many images as you want. View it from different angles. You want a probably combination of some shots that show the entire piece within the frame, and some shots that are close up that are cut by the frame. So that looks good. Now that everything's set up, all I have to do is hit print, and it's going to save. I don't want to overwrite that one, so I could even decide, from that same view, maybe I change the viewing type. They don't all have to be the same viewing type. And that's about it. It's just like taking snapshots. So later on, we'll look at a little bit at in the rendering function, how we can change the color of things and play with some of the outputs a little bit more. But that should be enough to get you going to be able to produce a series of fairly good images of your project and be able to post them.
Title of this video is Boolean Modeling and Figured Space. So in this video, I'm going to talk about issues that are specific to the next assignment that you're going to be working on, and really what that's about in terms of what you're going to go through procedurally, but also what it is conceptually, what it is you're going to be working on. Now, if the previous series of things that we did in the previous assignments were about creating something through addition, through taking these 3D solid forms and stacking them together, building them together to create something, this series of things that we're going to do on the assignment is about creating something through subtraction. What is meant by this term Boolean? Boolean is actually a term that comes from mathematics, and if we're using it in a computational sense, actually specific to coding, there's something called a Boolean variable. And a Boolean variable is something that's the result of a condition that can lead to either two things. So it can lead to either a true or false. So in this case, do the square and the circle intersect? True, they do, or false, they don't. And that's a Boolean variable. Now, in 3D modeling, it's related to that, but it's slightly different. So if we take the same condition, this square and the circle intersecting, in 3D modeling, a Boolean can actually result in three different conditions. One is a union. I can join those two things together to form one thing. One is an intersection. I can create the thing that's modeled through their overlap, or difference. I can subtract one thing with another. And this occurs both in 2D and also in 3D. Now, the one that we're really interested in for this exercise is this one, is difference. The issue that we can take something and we can take another form and we can subtract it out of that original form is of particular interest to us. And so what you're going to do in this assignment is you're going to start with a box volume, and you're going to be working with an expanded menu of 3D solid forms in that 3D solid creation palette. So you're going to be able to use spheres and toruses, and there's a whole bunch of different objects in there that you will be free to explore. But you're going to start with a box volume of a particular dimension. We want it to have particular proportions, and you're going to intersect that with a series of volumes and make subtractions from that. Now, something that's important to think about when you're making these subtractions is, can I make those subtractions actually overlap? Can I interconnect them? And can I have them contact at least one surface of the original volume? And what that's going to do is it's going to create a kind of spatial continuity between these different volumes. So what they're really going to do is sort of form one volume, or one void, I should say, that's subtracted from this original box volume. And you should be able to kind of sense that void as a kind of space or room within that volume. And that's really the goal of the exercise, is how do you kind of sense that void as a kind of thing within the box. Now, why are we doing this? What is this about? Well, for architects and actually quite a few artists, the idea that space is itself a medium that they work with is a significant idea. And here we're looking at two drawings by two Renaissance architects, Boulez and Lequeux, and you really can understand through these sectional drawings, which is a kind of slice through their project, you can really sense that space is a kind of object. It's a kind of thing they're like carving into some other material, and they're really sort of shaping that space through this kind of carving. So in Boole, we really understand the sphere as the architecture, as the project, and in LeCue, this sort of series of sort of carved spaces which create this path through the project. It's very cogent. We can really understand it through these things. This idea of space as a kind of object, as a kind of figure, is an important one to 20th century development in design, and is related to something called Gestalt psychology. And these are images. You might have seen these before. These images where either you're reading a vase or you're reading two faces, and this idea that the vase is both an object, but can also be read as a space between these two other things. It can be read as a kind of figure, is the idea that space can be a sort of figured thing. It can be an object that we see. Contemporary artist Rachel Whiteread, most of her work plays on this notion that space is a kind of object that we can read, and she makes these monumental plaster casts of essentially the interior of things. So on the left, she's casting the inside of a woodshed. On the right, a series of stairs. And literally, the space becomes an object, a new object in space. The architect Gordon Matta Clark, in his work in the 60s and 70s, he was working with abandoned buildings as his material, and he was making these sort of geometrical figured voids that were subtractions from the building. So you really, in seeing these photographs, you really sort of understand the void, the space, as a kind of object. After we make our subtractions from our volume, we're going to look at a really cool representational tool called a clipping plane. And a clipping plane is essentially this plane that we can move through space, and it kind of slices through any object that we put in contact with it. And it allows us to, like the Boole and the LeCue sections, it allows us to section our objects and really look inside and see those spaces that we create inside. So it's a really a very interesting representational tool that we'll explore in this project. We can also use the Boolean union tool. So we're not limited to just taking sort of one default object and subtracting it from the original box. We can actually make a much more complicated subtractive object by unioning different things together, and then we'll even look at how we can edit that thing that we want to subtract. We can squish it down, we can rescale it, we can sort of change it a little bit before we make that subtraction. And that's sort of one of the other things we'll look at. Now, like the last assignment, positioning is absolutely critical. So using your different orthogonal views, top, front, and right, to really understand where those volumes are in space. How are you really intersecting one with the other? You're going to need to really look at it from multiple viewpoints. There are a couple pitfalls with working with Booleans, and in this assignment, something to look for. So one thing is to not make too many subtractions from your original volume. If you make too many subtractions, what's going to happen is that original volume, the solid, is actually going to become the figure. And so you're going to lose this sense that you're carving out of something, and you're just going to be creating a sort of sculptural solid instead of really thinking about this space as the kind of object. The other pitfall with Booleans is sometimes you can get these little exclamation points, and what those refer to is that the geometry, for some reason, because of the way that you positioned the solids before you subtracted them, it's creating what's called a not well formed object. Now you'll still be able to represent it. It's not destroyed. If you were trying to do something like 3D print it, you would have a problem because it wouldn't be see it as a solid object. But what this alludes to is the fact that Boolean modeling is actually, it's a really, really interesting tool for designing with. But it has its problems. It's really not the best way to go about modeling complex 3D forms, because we know that our 3D models aren't really solid material that we're carving out of. They're actually composed of surfaces, and they have this interior void. And so Boolean modeling kind of confronts that. You run into some problems when you actually make too many subtractions. But that's fine for this. It's a very interesting tool to explore, and we'll use it in this exercise. And if you get these exclamation points, don't worry about it. You can always undo. Try moving your solid before subtracting. And so that's it for this. I hope you have fun with this exercise. I think it's a really enjoyable one.
So in this video, I'm going to show a few more tips and tricks and things that you can do with the gumball tool, and point out some things you might have noticed when you were doing the first assignment. So one of the things that might have happened when you were trying to move an object is you might have clicked once on one of the direction arrows and gotten a little dialog box that looked like this. And you can make that go away if you just click someplace else in the scene. You can deselect it. I think you could also do it by just hitting escape. We'll bring you back. So what that little box is, it allows you to, if I wanted to, let's say, move in the X direction, either a positive or negative, let's say I wanted to move 10 millimeters, I could do that. I could just type it in. So it's a way to allow you to move pretty precisely in space. And you could do that in any direction, in a positive or negative direction. So that might have been one thing you noticed. Another thing you might have noticed is that the orientation of the gumball, when you rotate it, that orientation changes. And then if I deselect it and then go back and reselect, that orientation has changed back to alignment to the C-plane in this case, but that's also happens to be the world coordinate system. So what if I wanted to, after I rotated this box, I wanted to kind of slide it along, one axis on one side. So in a sense, I wanted to have the gumball oriented to the object and not to the world or the seaplane. And the way I can do that is that there's this little handle that sort of comes off of the center of the gumball. And if you click on that, it'll open a dialog box which gives you a bunch of options. It allows you to do things like reset the gumball or change its alignment. So by default it's going to be aligned to the world, so it'll always realign itself to the world after you're done. But I could choose to align it to an object, and so it's going to align it to one side of the object, which would then allow me to slide that object along that axis. After I'm done, I could always click on that again and realign it to the world. Another thing you can do is if I let's say I wanted to rotate this object, but I didn't want to rotate it around its own geometric center. I wanted to rotate it around another point in space. So I can actually move my gumball if I hold the control key down and select an axis. I can drag the gumball to a different position in space, and I can then rotate the object. Now rotates around that new position in space. If I want to reset it or go back, I open up that dialog box and select Reset Gumball, and that'll bring it back to its geometric center. Another thing you can do is I can, and I'm going to do this, I'm going to align this to the object. And another part of the gumball you might have noticed are these little handles that extend off the other end of the axes. And what these allow you to do is what's called 1D scale, to stretch, to compress and stretch the object in that one dimension. So I just need to drag it, and I can stretch it in that dimension. If that gumball is reset, aligned to the world, it's going to stretch it now in that direction. So it's a pretty interesting tool which allows you to manipulate any object. Let's say if I had a cone here, I can stretch and sort of pull that object to manipulate it, its form. And that might be important for the next assignment, is you might want to play with the shape of your objects a little bit more when you're positioning them before using your Boolean tool. And so that stretching that with the gumball tool will allow you to do that. So those are just a few more things you can do with that tool. It's very handy. And I'm going to show you some other options using some basic transformation tools to manipulate position and scale of objects. I'm going to discuss something called object snaps, which allows you to snap to particular parts of objects, like endpoints or midpoints or centers. And I like to talk about them in conjunction with something called transforms. I'm not going to talk about all the transforms that we use. I'm going to talk about the main few that we use, which are located down here in the lower part of the sidebar. We have move, copy, rotate, and scale. And so I'm going to briefly talk about those in conjunction with these snaps or O snaps. So down at the bottom of the screen, or I think it's up at the top in Apple, you'll see something called O snap, and by default it's going to be off. You want to turn that on, and then it activates this box section of the interface here. And here I can select the particular parts that I want to snap to. So whether I'm snapping to the endpoint of an object, a point, a midpoint of something, a center, perpendicular. I might have intersection also on. Those are usually the defaults that I have on, and you can turn them on and off as you want. You can also disable your object snap here, or you can just turn it off here. you want to be careful with something like near, because near just snaps to anywhere on an object. It's not very precise. You only use that in certain circumstances. Vertex and quad have to do with meshes, so we won't use them that much in this course. So what does this allow you to do? Well, so I have a move, and this is a move like I would use with the gumball. So the question might be, why would I choose to use a move transform over using a gumball? Well, let's say I wanted to move this box up to the top of this box and very precisely position it within this front corner. Now, in order to do that, and you probably did a lot of this in the first assignment, you would go to a front view, move that box up and over, and then check it from another view, let's say the right, and so now I need to slide it over, and I would need to have my snaps on, which is fine. It's a couple steps, and it works just fine. But what if that was not within the grid? If it was sort of slightly off, or for some reason I had my grid snap off a little bit, so that thing was shifted off a little bit, and then I turn my grid snap back on. Well, I'm not going to be able to really precisely move it to that corner. So this is where the other transforms might come into place. So if I move it back, if I have my O snap on and I select move over here, and I see up in the command line it says select objects to move, I select that box, enter to select it, so I right click, and then I can select the point from which I want to move it from. So I'm going to select that front corner point. Since I have my O snaps on, it's snapping to that front, which is both an end and also an intersection. I then can move it precisely from that point, and it snaps to that top point. So it really allows me to very precisely, snap something into place. Now, I have this other box here. What if I wanted to move that up to this other corner along this face? So I could use my move tool again. Or maybe this time I'm going to produce a copy. So copy is essentially, you can do two things with copy. You do a copy move, so it's essentially another kind of move, or I could just copy something in place. So if I hit enter and I select in place here, it's just going to copy that object right on top of itself. The other way to do it is to select copy and then do a copy move. Right click, select that point, and I move it up there. So now let's say I wanted to rotate this so it matched up to this face. I could use my gumball and I could relocate it to that point, and it would be a bunch of steps, and I probably wouldn't do that. Use the gumball for that. I would use this rotate. So click on the rotate tool, select that object, and hit enter. Select the point of my rotation, which is here, and then I'm going to rotate it from that other end. And it's interesting because it shows me that, the plane within which it's going to rotate, which is handy. Then all I have to do is select another point along that line that I can snap to. So I could snap to that end there, or I could snap to the midpoint there. They're both along that edge. Now you might have noticed, and I can show it again. We'll do our rotation tool again. Select that object, select rotate, in that corner. That rotates within the plane that the C-plane is in. right? So it's rotating around to the orientation of the C-plane. Whether or not this object is on the C-plane, or it could be if I lifted it up in the air, it would still rotate in that plane of the C-plane. So if I wanted to rotate this along this face here, I would need to change the orientation of my C-plane to match that face. And so if I tilt the C-plane up to the right, and now I choose rotate again and rotate it from that corner, I can rotate it down, whoops, onto that face. If I have center selected, snap to center of object, that really applies to anything that has a sort of radial form, like a circle or a sphere. So if I wanted to use that sphere, move that sphere precisely from its center, I'd see I get that little send comes up, shows me that it's snapping to its center. And then I can move it and snap it precisely to that corner. So that's move and copy move, rotate. And then there's also scale. So we looked at with the gumball how you could use these handles to do a 1D scale. And that's the scale actually has a flyout here. So that's what that is right there. That's a 1D scale. 2D scale is usually used with 2D objects. If I wanted to scale up, let's say this whole collection of objects here, and that's something you might want to do when you're doing the Boolean assignment. Maybe you want to scale everything up together. So I can select that scale, 3D, and it asks me for a base point. So where do I want to scale from? So I need to select, I'm going to select that corner, and then click someplace else as my first reference point, and then I can pull, and it scales everything together. Or I can scale it up, or I can scale it down. Also with any of these tools, if I look up in the command line, with any of those tools, with rotate, with scale, I can produce a copy if I select it. By default, it's gonna probably say copy no, but I could produce a copy by selecting it. So those are just a few of the transforms and the object snaps. We're going to be using these tools quite a bit throughout the rest of the course, so we'll really come back to them. But there are a few of the things that you might want to use when you're doing this Boolean assignment. It's going to allow you to move objects into position in a much more precise way, and also to collect them together in groupings before you do the Boolean. So in this video, I'm going to show you the steps you go through to use the Boolean tool in all of its manifestations. The Boolean tool is located over here on the sidebar. It has a flyout. It's actually part of a much bigger palette of solid tools. We're only interested in the first four up at top: union, Boolean union, difference, intersection, and Boolean split. So in order to perform a Boolean, you have to have at least two objects, and they have to be intersecting. If they're not intersecting each other, then your Boolean tool is not going to work. Now the most common Boolean, the one that you're probably going to use most in this assignment, is the Boolean difference. So that's where you subtract one object from another. And if I select that and I look up in the command line, it tells me select surfaces or poly surfaces to subtract from. So I could subtract from more than one. I have one in this case, so I'm going to select the box first, and then I have to hit enter to continue. So hit enter or right click, and then it's asking me to select surfaces or poly surfaces to subtract with. It's also asking me, do I want to delete the input? By default it should say yes, and so I select the sphere and then hit enter again, and it subtracted the sphere from the box. I'm going to undo that. So if I do it again, difference, select that, right click, select the sphere, and I can say delete input no. And so that's going to leave me my original object. And you might choose to do that. You might choose to save your original objects, particularly if you've manipulated them a lot and you want to maybe continue to use them. You may decide to save them. So that's a good option to have. Okay. The other one we could look at is Boolean union. So union joins two or more objects together. So I just select the objects that I want to join, and then I hit enter. And then it creates one continuous volume out of those two objects. Now, why I might use that for this exercise, this assignment that you're going to work on, is, maybe I have I create a volume, and I have other volumes sort of attached to it. Let's even move, if we have our O snaps on, we could move this sphere from its center. Let's up to a corner there. This is where I would use the move transform and my O snaps. Then I could select these things all together and union them. So now they're one thing. And then move that to intersect that volume, and then do a Boolean difference. Right, all at once. So that could be an interesting way to proceed using the union. Now there's another thing we could look at, which is the intersection. So an intersection, Boolean intersection, that's just going to model the overlap between those. The last Boolean tool is sort of a combination. It gives you a difference, and it also gives you the intersection, and it keeps the objects too. So it's kind of a bunch of tools combined. The other thing you can do is you can subtract from multiple objects at the same time. So, if my original volume gets split, or if I have multiple elements that I want to subtract from using one object, I would select those, then hit enter, and then select my subtracting element and hit enter, which is going to subtract from both of them. So that's your Boolean tool, and I'm going to show a Boolean modeling example as an example of the assignment that you're going to be working on, where I take an original volume and I subtract a bunch of objects from it using the Boolean, the exact steps you would go through in the next assignment. So in this video, I'm going to run through an example of the steps that you would go through or could go through for assignment 1-2 on Boolean modeling. And these are suggested steps. You can vary these as you see fit, but you might aim for some of the things that I discussed within the lecture on Boolean modeling, these issues of creating a kind of figured space, a continuous space throughout the given volume. But really feel free to experiment with these things. You can always start another one, and we asked for at least three different versions, and you'll see you can do these things fairly quickly. So you can try a lot of things out, and you're not going to hurt anything by doing something incorrectly. You can always do another one. So what I'm going to do, I'm going to start by creating a new file. Small objects, millimeters, and I'm going to take my perspective window and increase it. So the first thing we'll do is create a box. Oops, let me pull this out here. And gave you a particular size, 50 by 30 by 70. So it's not a completely square box, it's kind of oblong. Now there's a couple, I was showing the method. I have my grid snaps, my O snaps, and my gumball on down at the bottom. Click on the origin and I can drag to 50-30. That's one way to do it. There's actually another way to click to that point, and that's to type up in your command line, type 50, 30. So I can type in my X and my Y values in that order, separated by comma. You don't want a space after the comma. If you put a space after the comma, it's not going to work. So 50-30, then hit enter, and now it's asking me for my Z height, and I can type that in also, and that's going to be 70. Just hit enter. Set our view to ghosted. Okay, so there's my volume. Now in this exercise, you're opened up to a number of other shapes, solid shapes that you can use. You can use spheres and ellipsoids and torus, not pipes, because that takes a couple of steps, but there is a torus you can use, tube. So feel free to experiment with those. I'm going to start with a sphere. So create it by clicking, then dragging, then clicking again. And I'm going to position that sphere to intersect my volume. Again, you're going to have to, the best way to do this is from your orthogonal views, so you can really see where you're positioning it. Back to my front view here. And so I want it up a little bit. And then I might go back to my perspective view and give a little arc rotate. See if it's where I want it. Seems okay. So now I'm going to do my Boolean. So under our solid tools here, second one is the Boolean difference. Click on that. So in the command line it says select the surfaces or polysurfaces to subtract from. I select the volume, hit enter. And here I can choose whether or not I want to delete my input. I'm going to say yes on this. And then select surfaces or polysurfaces to subtract with. So select the sphere and hit enter. And so it gives me that subtraction. So I'll flip that C-plane back down. I'm going to create a box. And if you remember, you don't have to just use these sort of straight solid creation tools. You can use a Boolean union to create an object, a subtractive object that's composed of more than one. So let's say I wanted to put a couple boxes on this box. Now I could use my snaps. I have my snaps on. I have end, point, mid, center, intersection, and perpendicular on. So I'm going to take that box and I'm going to snap it. It looks like this is set to object. I was playing around with that before. So let's set this back to align to world. That's what it'll be by default. So I'm going to move this. I'll select my move transform, select the corner of that box, and I'm going to move it up here. And then maybe we'll let's create another one. Again, I'm just experimenting, playing around. So move this one. If you saw that, since move was my last tool, all I have to do is hit enter. I'm just right clicking because that was the last tool I used, and so that comes up again. So I don't have to go back down here. If I'm using move a lot, I can do that, and then I just click on that. Okay, and so we might union these things together, select them all, and then select our Boolean union. And so now they're one object. So now I'm going to position that. Let's go to our top view. Rotate it a bit. Let's go to our front. Now you might ask, what am I looking for within this positioning? Well, I'm trying to get this second volume to do a couple different things. One, I want it to intersect that first volume because I want to create a kind of continuity through my volume between the different voids that I'm creating. So I really think of that figured space as one thing, as one continuous thing. Something that's like a path or like a series of rooms that are cut through this solid volume is how I'm imagining it. So I'm positioning this so it intersects that void, and the only way to really tell if it's doing that is to view it from a number of different positions. So I can see right here it cuts through, and maybe it's not cutting through quite enough for me. So maybe I'm going to stretch it a little bit. So I'm going to click on here and I'm going to set align that gumball to the object. And then I'm going to use my little handle here to sort of stretch, do a 1D stretch. Right, so I'm moving it a little bit more, so it's just intersecting a little bit more. That really stretched that in a crazy way. That's okay, we'll go with that. Wasn't exactly what I was expecting, but we'll see what it looks like when I subtract it. Again, I could always start again. Okay, let's do our Boolean difference. Select that, enter, select that, enter. Kind of a strange subtraction at the corner, but I'll go with that. So you can also change the orientation of this, like if I didn't want it in this kind of vertical orientation, maybe I'm going to rotate it down 90 degrees, and I can do that by, if I set my C-plane to front view, sort of along that front surface, because I'm going to rotate this within that plane. I guess I could use my gumball too, but I wanted to demonstrate how I would do this with the rotate transform. So if we select that, hit rotate, and then I can select where I'm going to rotate it from. So I'm going to rotate it from this lower corner point here, and it's going to rotate within the plane of that C-plane. And if I hold the shift key down, again, like with the gumball, it's going to snap to 90 degrees. Okay, I'm going to do one more subtraction, and you probably want to do at least 3. You could do more. You could do a minimum of 2. Again, feel free to experiment. Okay, I'm going to do a cone. This one, I'm going to rotate that. Let's look at it from the top view so I can get it positioned. Again, I want to intersect here. Maybe I'll rotate that a little bit. We'll have it like come out that corner. And let's move this forward a bit. Okay, let's see where it is positioned from the front. Okay. Now I think I want it to be sort of bigger up front here. I like that it's going back through this corner back here. So I'm going to stretch it out a little bit in this Z direction. That's better. And then I'll move this forward. Maybe I'll make it more vertical, sort of stretch it up so it's more like a kind of doorway. There we go. Cool. Now it's a kind of door going through that corner into this vault. All right, let's do our difference. Enter, enter, and we got our doorway going through. So I have a kind of path coming into that space, and I view it in perspective. this skylight cutting up through there, and entry from there. So I have a sort of continuous path going through. It's a kind of figured space within the whole. I'm not destroying the whole volume to the extent that it becomes this other object. If I was to work on this more, maybe I would connect sort of from that space down into this void. But we'll go with that for now. And so then I'm going to save it. Under lesson 1, we'll call it assignment 1, 2. So I hope that helped explain a few things, and in the next video I'm going to show you how we can use something called a clipping plane to view sort of sections through this model in different ways. So in this video I'm going to show you how to use a special representational tool that will allow us to take our model and, in a sense, slice it or produce a sort of slice through it, which will allow us to kind of see inside of it in different ways. Since this model is a lot about this kind of interior figured space, we want to be able to reveal that space through some of our representations, and the clipping plane tool allows us to do that in a really efficient way. So the first thing I want to do is I want to decide on the orientation of my clipping plane, since I'm going to create it within that orientation. Although we'll see we're not going to be fixed to that, because the clipping plane really becomes a kind of object in the space that we can move around and rotate just like any other object. So we could sort of change its plane that it exists in, and I'll demonstrate that. But I'm going to start with it in the front view, so I'm going to set my C-plane to that front. And then under my viewport heading in that pull-down menu, I'm going to go all the way down to the bottom and select clipping plane. And then I'm going to drag in the window this plane. It's going to be created on that C-plane, and I just want the clipping plane to be a little bit bigger than the face of my volume. So I'm going to start sort of out here a little bit, click once, and then drag, and then click again, and it creates that plane. So it sort of looks like a transparent or wireframe surface. Now I can click on that plane, and I see I get a gumball, and I can drag it in different directions. So if I drag it in the Z direction here, you can see it sort of slices my model away, which is really pretty cool. I'm in the ghosted viewing style, and so what it's showing me is the sort of interior of my volume, because if we remember, solids aren't really solids. They're made up of surfaces, and those surfaces have this sort of other interior, which is it's a pretty interesting way to look at this, because I'm looking at really, you know, two spaces, a sort of interior space here and another interior space inside that volume. So that could be a pretty interesting way to show your project, and it also allows me to see these conditions inside that volume that I couldn't normally see any other way. I would need to sort of cut my volume up to be able to see that. The other thing you might want to do is you might want to change your viewing style to rendered. If I change it to rendered, you'll see it'll treat that whatever that clipping plane cuts through, the surface of the clipping plane. It does a couple of things. It makes it solid, so it sort of treats the clipping plane as a sort of other surface that it fills in, and then it also makes my edge a darker line, which allows it to read really well. So you might want to use that. And what you're going to do is you're essentially going to position it in spots where you feel it's best revealing your project, and then you're going to produce print some images from that, like you did with the last assignment. So I would print those out, and I've gone through that before. Other interesting thing here too is that since the clipping plane is a kind of object, I can rotate it, right? So that's going to give me a sort of different positions. I can, if we undo that, I could rotate it completely in another plane, 90 degrees. So now it's sort of showing up a kind of plan section of my project. And so with this assignment, you're probably going to want to have a bunch of images that use your clipping plane to show your project. And then you're probably going to have, and I can hide this. Oh, if I unhide it. You can just move it out of the way. Right. If it's totally outside of the object, it still exists, but it's not going to cut through it. And I'm probably going to show my project through some views that sort of show the whole thing. I could show it in, even just dead-on orthogonal views might be interesting for this, and something that shows the interior and exterior. Maybe even something like a wireframe could be interesting to show the project. So experiment with a bunch of different ways to show it. Experiment with the clipping plane. That's certainly a useful way to show it, and have some fun with this project and making some figured space.